Hi, my name is Lukas Kosinski and I am the CEO of SciStudio, software and hardware engineering company focusing mostly on the medical sector. This video is part of our Qt Medical Software course. In this series, we talk about main concepts of medical devices software development that you, as the founder or the CTO, should know. All of this should correspond with the realms of making software products using Qt, C++. And those technologies is our technology of choice in many projects. So that's why we made this course. In this episode, we will focus on medical devices software architecture. You might ask me how medical software architecture differs from designing architecture for other types of software. Well, we can say that it does not differ in any specific way. However, there is one thing that I personally find essential. In the world of software development, there are a lot of talks about best practices, quality, and so on. However, in many companies, such slogans are a cliché, a platitude, but in the medical sector, it's a must-have. It's a must-have without which you won't last long. So, from this episode, you will learn what are the most important aspects of medical devices software architecture, what the regulatory standards say, and what Qt has to offer in this regard. Stay with me and enjoy. So, the most popular standard for medical device software is 62304. Though complicated, I kind of like it. This course focuses more on solutions, not regulatory, so sometimes I will simplify a bit to focus more on practical knowledge. So as always, the standard does not tell you how you should approach a particular thing, so you have kind of flexibility of choosing your methods and doing things your way. It does tell you two things. First, you have to document architecture describing software's structure and identifying software items. Let's call it a high-level documentation. And you have to prepare interfaces documentation, so the actual communication between system components. The processes described in 62304 enforce that architecture should be based on the requirements of software. Actually, it makes a lot of sense that you should first note down all the things that your software should do, then design the system that would actually make it possible. And only then you should sit down to coding. An important thing is that standards don't force you to document all single classes, only high-level components and interfaces. If you think about that, it also makes sense, as it's not possible to plan how you call all the single features before actually doing that. So, depending on the complexity of your device and number of physical elements, your software detailed design SDD document can be really big. Here is the demo of a patient's vital parameters monitor that measures breath and heart rate using this small contactless radar here. How high-level documentation for this device could look like. Of course, that's a tip of an iceberg of your documentation, but there is a simple diagram showing us this idea of having software items and their interfaces identified. On the diagram, you can see main software items along with the serial port UART interface used to communicate between actual software running on tablet and the radar. Okay, but this tutorial is mostly about using Qt for medical software development, and this is actually the expertise of SciStudio, my company. So, what are the advantages of Qt in terms of having nice software architecture? First, Qt has mechanisms that help you design an architecture in a modular way. That means that in Qt, there are handy ways of creating your own modules. your own libraries and plugins. For example, there is a cool set of CMake commands like Qt add QML module that help you organize your code base in portable modules. Also, in the case of complex medical devices with robots and so on, it could be nice to split the functionalities across multiple applications or services, and with the right skills and approach, it will mostly pay off in the future. Yeah, but of course, it all depends on the case. The next thing is that if your device has a user interface, then you would most likely code it using Qt Quick, module of Qt that is designed to develop GUIs using other programming languages than C++. It integrates really nicely with C++ in a way, but still, due to the fact that it's a separate language, it creates kind of a division between your logic code, hardware controllers, and GUI. So that's how Qt makes your code even more modular without you asking for this. Of course, it's also necessary to have an experience in doing this right, as developers have a tendency to put too much logic on the QML side. The next useful mechanism is model view programming. Qt's model view is like its own cool version of model view controller paradigm, and the model handles here your data and logic, while the view takes care of showing it on the screen. Instead of a controller, Qt uses a delegate QML item to control how items look and behave. This setup keeps your data and UI separate, so you can tweak one without messing the other one. And then another nice thing is that Qt makes it super easy to connect models and views, saving you a ton of time. If you have a moment, I encourage you to visit the Safe Studio website and our blog. Links are in the description. Also, please hit the like button and subscribe to our channel. Let me know in the comments how do you like this course, how do you like this episode. This way you help us spread our message to other people. Another helpful aspect of Qt that simplifies designing a nice architecture for your medical software is the fact that it has a lot of communication modules included. But by that I mean modules for networking protocols like HTTPS or TCP/IP. I mean modules for inter-processes communication like dbus, for inter-devices communication like serial port or UPC UA, for other communication methods like Bluetooth or NFC. In the next episode of this tutorial, there will be more about communication protocols. And there will be also more about HL7, Fire, and so on. For now, I just wanted to say that thanks to the fact that all of those modules are already part of Qt, you do not need to use any third-party libraries that have different API than Qt and so on. And this means that you reduce your technology stack, which is good for the architecture. Additionally, all modules have similar API, which would be convenient in use for Qt developers, even if they didn't implement a particular module in the past. With so many communication modules included, Qt also limits your regulatory efforts, as with less third-party dependencies, you have less software of unknown provenance pieces in your project. And the last characteristic of Qt that is good for your architecture is the fact that Qt is cross-platform. So in case your project consists of, let's say, several microcontrollers, main embedded HMI, and a mobile app, you can use Qt and share code across all those platforms. Okay, thanks a lot for watching this episode. I hope that now it's clear how Qt helps you design a great architecture for medical device software. If you need experts in regard of Qt or medical software development, feel free to contact Safe Studio right away. Links are in the description. In the next episode, we will talk about communication mechanisms and networking. We will also talk about cybersecurity, things typical for the medical sector. We will talk about HL7. So see you there.